To solve the inequality, we really just need to rearrange this equation for x. So we're going to add 8 to both sides, and we're going to end up with x is less than 8. Now, we do have to worry about flipping the sign. The only time we flip the sign is when we either multiply or divide by a negative. So if there's a negative coefficient on the x, that's when we have to worry about that. In this case, with no flipping the sign, so once we have the solution, we're going to have x equals 8, and we want the left side, or the smaller side, we're going to keep that circle open to indicate that it's not equal to. So here this is asking us to use sign analysis to solve the following. Really, we don't need to use sign analysis. This is kind of an extra, but we do need to solve this inequality. So we're going to solve this inequality first, and then we're going to see how sign analysis works. So for inequalities, again, if it's less than 0, the boundary is 0. So we're going to solve this inequality for 0. So I need to factor this. So I'm going to factor this x minus 6, x plus 1. And so I know my boundaries are going to be at negative 6 and positive 1. So I'm just going to go draw my solution out here. And there's a few ways I can do this. So there's 6 and there's negative 1. And we can just test our solutions. We can test solutions by testing coordinates. For example, 0. So we can test x equals 0. We're going to end up with negative 6 less than 0. That's a check. So we can probably make a fairly strong assumption that this is my solution in here. Okay, I can also test values outside of that domain. So x equals 7. If I do that, I'm going to end up with, I'm just going to plug it into the factored form. So here we get 1 times 8. So 1 times 8 is going to be 8 is less than 0. That fails my test. So that region out here, this region out here at 8 is not a solution. And then I can test x is equal to negative 2. So when I plug negative 2 into there, I get negative 8 times negative 1. Again, I get 8 is less than 0. That fails. So over here at negative 2, that fails our test. So that's going to be the much easier way to do this. However, it is good to understand how we could do sign analysis. So if I have sign analysis, the way it works is this. So I have my values at negative 1 and positive 6. Okay, and I can see what's going to happen to each of the factors when I plug in numbers at, for example, here. If I plug in a number over on this side, okay, when I do my sign analysis, I'm going to end up with some negative number, and and just so we're clear here, I'm plugging into these factors here. Okay, so when I plug into those factors, again, I'm not looking for positives or negatives. So if I plug in a negative number, I'm going to end up with a negative value here in that bracket. And I'm going to end up with a positive value. I'm going to end up with negative there. So this is going to be positive, which fails my test. It's actually above the x-axis, but I want below. Okay, so I can do the same analysis over here. I'm going to end up with negative, positive. Okay, and that's going to fail my test in there. Okay, actually I don't need to do that here. That's a bit redundant. Okay, so then I test the next region. So I'm going to test the next region here. If I in between here, so if I plug in a number between negative 1 and positive 6, I'm going to end up with a negative for the first bracket. and I'm going to end up with any numbers in between -1 and +6 are going to, for the second bracket, it's going to give me positive. So that equals negative. So that is a check for that region. Okay, so this region in here is a region that we will consider as part of the solution. And then I could do my sign analysis in this region over here on this side. And when we plug in numbers bigger than 6, if I plug it into the green bracket, I'm going to end up with positive. If I plug it into the red bracket, I'm going to get positive. And again, that's going to be a positive value, just like I got here. This fails my test, so this is this area here, this region, we don't want. Okay, so this is an X here, we get an X here, and we get a check in here. So we can do sign analysis in this way by testing the signs just in those different regions. Again, I'm not actually calculating the values, I'm just testing the sign. Now, this sign analysis is good when we don't actually know numerical values. Here we actually know the numerical values. So it would be much easier to use this type of analysis is actually just plugging in and actually working out values. But it is good to start understanding this idea of sign analysis. Okay, this is not something we use a lot in grade 11, but in grade 12 in calculus, we have to do sign analysis often because we don't know the values of the numbers that we're dealing with. And we can just only work with sign values, whether things are positive and negative, and how they combine with each other to get a positive result like we have here, a negative result like we got here, or a positive result like we got here, and we can work out the region values based on that.